Problem number 2 asks us to use the 2 following columns of water that are given in the diagram below, and with those 2 columns of water to find out what the pressure is at the bottom of each tank and which tank has the larger outlet velocity. But it doesn't just ask us to find those values, it asks us why. And so we're going to have to do a little bit more explaining and deriving in order to give a complete answer here. Some assumptions we're going to make is that, from the diagram we can pretty clearly see that H1 is greater than H2. We're going to assume that each of the tanks have the same fluid and have the same value of gravity acting on them. If you remember from fluids, we already have an equation given to us that explains what the pressure is in, a body of water given the height. And that's just that the pressure is equal to the density times gravity times the height. And so, we could answer part A by saying that, pressure 1 at the bottom of the tank is P1 equals rho GH1. And pressure 2 is equal to P2, which is just rho GH2. However, part A asks us why, and so let's dive a little bit deeper and explain that answer a little bit better. So to start, let's look at what pressure is to start. And so we know that pressure is just equal to force over area. And we know that force is just equal to mass times acceleration, so we can say that pressure is equal to mass times acceleration over our area. Then let's look at mass for a second. We know that mass is just equal to a volume times a density, right? So we got mass is equal to volume times a density. And we can further break down volume into area and a height. So now we've got, pressure and height, which are kind of the 2 things that we have in this equation. So we get mass is equal to area times height times density. So if we go ahead and substitute that in, we can get that our pressure is equal to area times height times a density times an acceleration all over area. And so then we can cancel out our areas and we're left with a pressure is just equal to height times a density times an acceleration. And so in this equation, we know our acceleration is just due to gravity. And so we're left with that original equation that we know from fluids, which is just that our pressure is equal to density times gravity times height. And so that gives a little bit better of a why behind this equation rather than just going ahead and, regurgitating the equation you already know. You can better explain the why. And so they ask you, what is the pressure at the bottom of each tank? You can give a very complete and well thought out answer by just going through, pressure and mass, rearranging a few things, canceling them out, and you're left with your final answer. Tank 1, the pressure is going to be P1 is equal to density gravity height 1, P2 is equal to density times gravity times height 2. And so that's how you do part A of this problem. Part B asks us to find out which tank has the larger outlet velocity and why. And so the one assumption that we're going to make here is that the 2 outlet areas are the same. So those little spouts have the same area. And if we make that assumption, we can go back to what we've solved in problem 1, where we solved for the velocity at the outlet. And in problem 1, we found that, V outlet is equal to square root of 2 times our gravity times our change in height, where that delta H is the distance between the height of the tank and the height of the outlet. So in this case, the outlet's right at the bottom of the tank, so that delta H is probably just going to be equal to the respective height of the tanks. But if you want to go and look how to derive that and get the velocity of the outlet, go check out problem number 1 in the thermodynamics playlist, or sorry, in the fluids playlist, and that will explain to you how you get that velocity. And so that's how you would answer part B of the problem. You'd go through and kind of derive out the velocity of the outlet, and that's how you do this one. Hope that helped.